This question from the November 2018 grade 12. Question 8. PON is the diameter of the circle centered at O. TM is a tangent to the circle at M, a point on the circle. R is another point on the circle such that OR is parallel to PM. NR and MN are drawn. Let M1 be equals to 66 degrees. So M2 is equals to 90 degrees because it is the angle subtended by diameter PON. And P is equals to 66 degrees because of the tan chord theorem. And then this is equals to 90 degrees because we have an F there. So this is 90, and then these lines are parallel. So that's a 90. Okay. And then O2 is 66 degrees as well because of the F. So this angle should be equals to that angle, corresponding angles. Okay. Let's answer questions. 8.1.1. The size of P. Well, M1 is equals to P, which is equals to 66 degrees, and that's because of the tan chord theorem. 8.1.2. M2 is equals to 90 degrees. Angle in semicircle. 8.1.3. And then they are looking for N1. So in triangle MNP, we know that P plus M2 plus N1 should be equals to 180 degrees. And this is because of the sum of the angles of a triangle. So therefore, N1 is equals to 180 degrees minus 66 minus 90. So I'm getting 24 degrees. So that's 24 degrees. And then they want O2, 8.1.4. We said P is equals to O2, 66 degrees because of corresponding angles. PM is parallel to OR. 8.1.5. The size of N2. In triangle ORN. So I'm focusing on this triangle right here. OR is equals to ON because they are both the radius of the circle. So this angle should be equals to the whole of that angle. So we will say that ORN is equals to ONR because of the radii. OR is equals to ON. And then O2 plus ORN plus ONR should be equals to 180 degrees. And this is because of the sum of angles in a triangle. O2 is 66 degrees plus. So I'm going to repeat the whole of N 2 times because it is equals to R. So this is going to be 2 ONR is equals to 180 degrees. So ONR is equals to 180 minus 66 divided by 2. so I'm getting 57 degrees. And then ONR is equals to N1 plus N2. This is 57. N1 is 24. N2. So this means that N2 is equals to 57 minus 24, which is 33 degrees. Then question 8.2. In the diagram, triangle AGH is drawn. F and C are points on AG and AH respectively, such that AF is 20 units, FG is 15 units, and CH is 21 units. D is a point on FC such that ABCD is a rectangle with AB also parallel to GH. The diagonals of ABCD intersect at M, a point on AH. AB is parallel to DC, and this is because the opposite sides of a rectangle are parallel. And then the diagonals of a rectangle, they bisect each other. So I know that this should be equals to that. This should be equals to that. Okay. 8.2.1. Explain why FC is parallel to GH. Well, this is because AB is parallel to DC. Opposite sides of a rectangle are parallel. So it means that AB is parallel to FC, which is parallel to GH. 8.2.2. Calculate with reasons the length of DM. Okay. So in triangle AGH, so I'm looking at this. I can see that AF over FG should be equals to AC over CH. This is because of the line parallel to one side of a triangle, and that's FC, which is parallel to GH. AF is 20, FG is 15, AC, that's what I'm looking for, 21. So AC is equals to 20 times 21 over 15. So I am getting 28 units. So the length of AC is 28. It's 28. But we know that the diagonals should bisect each other. So it means that AM is 14 and MC is 14. This is true for the side 14, 14. So we will say AM is equals to MC, which is equals to 14 units. And we'll say the diagonals of rectangle bisect each other. And then we would say that dm should be equals to 14 units. Question 9.1, that's a proof. And then 9.2. In the diagram, a smaller circle ABTS and a bigger circle BDRT are given. BT is a common chord. Straight lines STD and ATR are drawn. Chords AS and DR are produced to meet at C, a point outside the two circles. BS and BD are drawn. A is equals to X and R1 is equals to Y. Okay, so if we focus on this the circle, we can see that B1 should be equals to X because of the angles in the same segment. So this B1 should be equals to X, and then you can see that BTRD is a cyclic quadrilateral because four corners all touch what? The circle. So it means that B2 must be equals to Y. Okay. Yeah. 9.2.1 A. Name giving reasons another angle equals to X. So you will say A is equals to B1, which is equals to X. And this is because of the angles on the same segment. And then B, R1 is equals to B2, which is equals to Y. And this is because of the exterior angle of a cyclic quad. 9.2.2. Prove that CDB is a cyclic quadrilateral. So this I need to prove that this angle is equals to the whole of that. Well, first of all, T2 is equals to this whole angle because it is the exterior angle of the cyclic quad. So T2 is equals to the whole of D, exterior angle of a cyclic quad. But T2 is equals to S1. T2 is equals to S1 because they are angles on the same segment. So this means that S1 is equals to the whole of D. So I have proven. Therefore, SCBD is a cyclic and then the reason is the exterior angle of a cyclic quad is equal to the interior opposite angle. 9.2.3. It is further given that D2 is equals to 30 degrees. So this is 30 degrees. And AST, so this whole angle is equals to 100 degrees. Prove that SD is not a diameter of the circle BDS. So I need to prove that this angle is not equals to 90. If I can prove that the whole of B is not equals to 90, so I'll prove that SD is not a diameter. Remember, this is X and that is Y. Okay. Look at this triangle right here. So this angle should be equal to that plus that. So we will say AST should be equals to D2 plus C. The exterior angle of triangle is equals to the sum of the interior opposite angles. This is 100. D2 is 30 and then C. So it means that C is equals to 70 degrees. We've proven in 9.2.2 that SCDB is a cyclic quad. So it means that, let's just write this. So it means that C plus B must be equals to 180 degrees because the opposite angles of cyclic quad are supplementary. C is 70 degrees and then B 180 degrees. So it means that the whole of B is actually equals to 110 degrees. Since the whole of B is not 90, it means that SD is not a diameter. Question 10. In the diagram, ABCD is a cyclic quadrilateral such that AC is perpendicular to CB and DC is equals to CB. AD is produced to M such that AM is perpendicular to MC. Let B be equals to X. Okay. So in triangle ACB, this is going to be 90 degrees minus X. CB and DC are equal chords. Equal chords subtend equal angles. So this is 90 degrees minus X. Okay. And then D2 is equals to X because this is a cyclic quad. And then this exterior angle should be equals to the interior opposite. So that is equals to an X. Okay. So it means that C2 must be equals to 90 degrees minus X. Okay. And this is 180 degrees minus X because of the angles on a straight line. So 10.1.1. Prove that MC is a tangent to the circle at C. So if we can prove that this angle is equals to that angle, then MC is a tangent because of the tan-chord theorem. Well, we can see that C2 is 90 degrees minus x, and then A1 is 90 degrees minus x. So MC is a tangent. So we just need to write it out. Okay, so in triangle ACB, angle ACB plus B plus A2 is equals to 180 degrees. This is the sum of angles of a triangle. Then ACB, that's 90, B, that's x, plus A2. So A2 is equals to 90 degrees minus x. And then we said A1 is equals to A2, 90 degrees minus x, because they are both subtended by they are subtended by equal chords. So we'll say equal chords subtend equal angles, and then we write the chords DC is equals to CB. Okay, and then we say D2 is equals to B. Exterior angle of the cyclic quad. And then in triangle DMC, we know that D2 plus M plus C2 should be equals to 180 degrees. Sum of angles of a triangle. This is x, that's 90, plus C2. So C2 is equals to 90 degrees minus x. Therefore, MC is a tangent. And this is because of the converse of the tan chord. (10.1.2). So I need to prove that triangle ACB, so triangle ACB is similar to triangle CMD. So C in triangle ACB and triangle CMD. Okay, so A2 is equals to C2 because they are both equals to 90 degrees minus x. And then C is 90 degrees. So ACB is equals to DMC, 90 degrees. So this means that B is equals to D2 because they are both equals to x. Therefore, triangle ACB is similar to triangle CMD. Angle, angle, angle. Then 10.2. Hence or otherwise, prove that CM squared over DC squared is equals to AM over AB. So we'll just use the similar triangles. So AC over CM should be equals to CB over MD, which is equals to AB over CD. So here I have CM and I also have DC, and then I have AB. Okay, so at least I need to have at least 3. So this is AC over CM, which is equals to AB over CD, and this is because of similar triangles. Okay, so AC multiplied by CD is equals to AB multiplied by CM. So I want to have CM on top. So CM over and then CD at the bottom. So this is going to be equals to AC all over AB. So I need to figure out a way to remove the AC because I don't have any AC there. Let's see. So I have AM. Then I'm going to go and look for AM. AM is right there. And then I have CM. CM is that line. So I'm guessing it's going to be this huge triangle. And then I also have DC. So I think it's going to be this triangle. So we have 2 triangles to compare. So we'll say in triangle AMC and triangle DMC. So M is common. M is equals to M because it is common. And then we've said that C2 is equals to A1 because they are both equals to 90 degrees minus X. And then it means that ACM should be equals to D2, that angle of a triangle. So therefore, triangle MAC is similar to triangle MCD. And then we just take the ratio. Let's just say MA over MC is equals to AC over CD, which is equals to MC over MD. So it's MA over MC, AC over CD, and then MC over MD. Let's see. Okay. So I have AM, I do have there. MC, I do have. And then AC over CD, I do have AC. And then I do have that as well. Okay, so AM over MC is equals to AC over CD. Similar triangles. So this means that AC is equals to AM multiplied by CD all over MC. So I'm just going to substitute AC into that. So Cm over Ct, Cm over Ct should be equals to AC over AB. So AC is AM multiplied by CD over MC. And then all of that should be divided by AB. Cm over CD is equals to AM multiplied by CD over AB times MC. And I'm just going to cross multiply. Cm multiplied by MC, that is going to be Cm squared, and then multiplied by AB. And then this is CD squared multiplied by AM. Then I'm just going to fix this. Cm squared over CD squared is equals to AM over AB. So it's proven. Then 10.2.2. I need to prove that AM over AB is equals to sine squared x. So AM is right there. And then AB, line AB is there. So it has something to do with the sine. Okay, so I'm going to work in this triangle. And I'm also going to work in that triangle. In triangle AMC and triangle ACB, the sine of ACM is equals to AM all over AC. So this is sine of x, which is equals to AM over AC. Okay. And then on this triangle, the sine of B is equals to AC over AB. So sine of x should be equals to AC over AB. And since I have a squared there, so I'm just going to take the first and multiply it with the second. So I'm taking 1, multiplying it with 2. So I'm going to have sine squared x is equals to AM over AC multiplied by AC over AB. Sine squared x is equals to, this takes care of that, so AM over AB.